Welcome to SGITMYSTR. Today, we're exploring the evolution of retrieval generation, or RAG, from simple search to get to like, share, comment, and subscribe.
We've all been there. You type a specific question into a search bar, hit enter, and get bombarded with thousands of results. And somehow, absolutely none of them answer your question. For decades, search engines didn't actually understand what you were asking. To early systems, human language was invisible. They only recognized individual words as empty, meaningless symbols. An inverted index mapped vocabulary words directly to specific text documents. If you type "help Python," the system only looks for the keyword. It can't tell a programmer fixing a bug from an owner with a sick snake. Both get lumped into the same pool. To sort through that pile, early engines simply counted how frequently those exact keywords appeared on a page to guess its relevance. If a page said Python 20 times, it ranked higher. The entire burden of discovery was on you. Because the machine couldn't understand human intent, you had to learn how to speak search engine, typing the exact right words in the exact right order to get what you needed. To fix this, engineers had to stop treating text as isolated symbols and figure out a way to translate meaning into math. As the VO says converts words, the text morphs into the numbers. This is achieved using vector embeddings. As you can see in this animation, the process takes a piece of text and converts words into high-dimensional numerical representations, allowing the computer to process them mathematically. These numbers aren't random. Large neural networks process massive volumes of text, analyzing how words appear in context over millions of sentences. Over time, the network learns to assign similar numbers to related concepts. As the VO says plot tightly together, the dots for coffee and espresso converge. If we plot these numbers onto a 3D spatial map, you can see the results. The words coffee and espresso plot tightly together in one conceptual neighborhood, while an unrelated word like house lands completely isolated on the other side of the map. If we bring this back to our help Python query, semantic search allows the system to approximate what you actually mean. By mapping the context of your other search habits or the specific phrasing you used, it navigates to the correct neighborhood of intent, even if your exact keywords aren't perfect. Semantic vectors turned machines into high-speed librarians. They could navigate to the right shelf, but the system remained limited to retrieving pre-existing documents. Then, large language models arrived. By training on a massive corpus of text, LLMs learned how to predict language patterns to generate entirely new, custom answers on the fly. But these models have a critical bottleneck. Their knowledge is frozen at the exact moment their training ends. If you ask an LLM about recent events or your company's private data, it doesn't know the answer and will confidently hallucinate a completely fabricated response. The engineering solution to this frozen memory problem is called Retrieval-Augmented Generation, or RAG. It combines the precise document finding of semantic search with the conversational generation of an LLM. This flowchart shows how a standard RAG pipeline works. First, the user asks a question. The system searches an external database for relevant documents, retrieves them, and then feeds those specific documents directly to the LLM to generate an accurate final answer. This external memory system drastically dropped hallucination rates. Instead of guessing, the LLM could now cite specific sources, adapt to new information, and operate safely in specialized fields without requiring an expensive retraining process. Still, a traditional RAG setup is entirely linear. If the initial search pulls up outdated or incorrect documents, the LLM will accept them without question and generate a flawless-sounding but totally incorrect answer. We successfully gave AI a reliable external memory, but the system itself remained rigid. It could faithfully follow a straight path of instructions, but it had no ability to pause, evaluate its findings, or actually solve a complex problem. That brings us to the current era of AI agents. We are moving away from simple, pre-programmed pipelines and building complex, autonomous decision-making systems. Let's run our ambiguous help Python query one last time. An AI agent processes this challenge completely differently than a traditional RAG system. This diagram illustrates an internal reasoning loop. The agent evaluates if search is necessary, decides which databases to query, and analyzes the results. It can invoke APIs, cross-reference sources, and crucially, if data is bad, rewrite its query and try a new path. Retrieval is no longer a fixed step trapped at the beginning of a linear process. It is a dynamic tool, invoked continuously as part of the machine's active reasoning. Artificial intelligence is expanding beyond text generation. The current frontier lies in building systems that autonomously hunt for the truth, shifting the heavy burden of discovery from the human to the machine.
First, keyword search matched simple symbols. Then, semantic vectors captured intent. RAG tied LLMs to external data. Now, agents use tools and reason.